Hello everyone! At MatchID we are truly thrilled to announce our newest software release. MatchID is a company that develops quantitative imaging techniques to assess materials and structures. Hereby, we not only optically record displacements, strains and accelerations. We fundamentally integrate our solutions within the complete engineering process of design optimization. To this purpose, specific attention is paid to quantitative results interpretation. Moreover, we seamlessly translate optical data into material properties, establish a true digital twin between experiments and simulations, and integrate with modal analysis solutions. Finally, our advanced training and documentation allows our community to get the most profound insights into their test results and analysis. This ambition we fulfill at the experimental setup stage by offering flexible and customizable hardware from low to high-speed imaging, but more specifically via our dedicated acquisition software, embedding speckle analysis tools, solutions for vibration and fatigue measurements, and a real-time DIC platform allowing for experimental feedback and machine control. Our post-processing solutions have a modular structure built on top of our central correlation kernel. The performance analysis module generates intuitive charts for signal-to-noise quantification. Our numerical deformation module allows to set up virtual experiments, accordingly enabling you to optimize your test setup virtually before entering the lab, or get insights into your measurement bias. The virtual fields platform integrates material identification, whereas the FE validation module establishes a true link between simulation and experiment. These can all be invoked from a multi-camera perspective. In our newest release, we elaborate further on those key points. Our image acquisition software communicates now with a broad range of webcams, giving our solution a low entrance level for educational goals. Secondly, the natural embedded speckle analysis and focusing tools, allowing for metrological speckle pattern evaluation and diagnosis of aliasing, are now also consultable via mobile devices. A simple QR scan allows to wirelessly optimize each individual camera. Next to these, the real-time DIC platform received a fundamental upgrade, integrating a plethora of extra functionalities. As such, thousands of data points can be analyzed in live mode without compensating for accuracy and precision. Moreover, adjustable multi-axial extensometers allow to create and align a spectrum of transverse extensometers. This allows to track deformation data in a vast amount of transverse locations. As such, when necking occurs, the one witnessing the largest strain can be allocated for machine control. The MatchID correlation kernel adopts now an intelligent incremental correlation scheme to monitor large displacements, rotations, and deformations. Hereby, one does not continuously update the reference image, but only at selective stages when a threshold criterion is met. Accordingly, noise is reduced to a maximum extent, while still being able to correlate over all imaging stages. As a result, one is able to fully monitor the entire rotation of tires while keeping the strain noise floor as small as possible. Our final major achievement relates to our virtual fields module for material identification. The user is no longer restricted to a long list of hard-coded material models, but can now also seamlessly embed his custom material model. This long time expected feature is fully open for debugging and comes with a complete software SDK supporting your own programming language of preference. Whether it's MATLAB, Python, C++, or .NET, MatchID communicates directly. We deliver you strains, you convert them to stresses. Finally, the virtual fields method is used as a true solver, establishing full equilibrium between internal and external work at every load step. Automatically allocated virtual fields guarantee an optimal signal-to-noise performance of the identified parameters. As a result, custom material properties for your constitutive model are identified, providing an integrated sensitivity analysis and yielding stresses at various load stages. Are you interested in our solutions or you want to apply for an upgrade? Please contact us at matchid.eu.